Hello, we're going to have a look at what the internet is in this video and cover a few concepts which are essential for understanding upcoming topics as well. So, the internet, we can give a very short definition for. This is a worldwide collection of computer networks. It's often described as a network of networks. The internet itself is a WAN, but it's made up of millions of LANs connected together using shared infrastructure. Now, a really important concept to start to develop now and in the next few videos is to send data over the internet, it must be broken down into smaller packets. A packet is an individual chunk of this message being sent. So messages never get sent in one go. They're always broken down into smaller packets. So here's a message which might be part of an email, it might be part of a WhatsApp. This wouldn't get sent in one go in the equivalent binary. It would have to get broken down into packets which contain the equivalent binary of just a few chunks of this. Now, how big the packets are really depends, really varies based on the protocol you're using, which we'll look at in a couple of videos' time. But here, let's say each packet can only contain 5 characters. We'd have to split it up like this. And we'd have to do this to send data over the internet. It's just how it's designed to work. And the whole system is designed so that packets are able to travel down different routes, right? The internet is massively complex. We've got this huge collection of all these different networks. There are lots of different pathways to get from your source to the destination. And packets are designed and actually encouraged to go down different routes. And as we've talked about, routers sit between each of these networks, and their job is to make sure packets get to the right destination, but also to decide what route to send them down. Now, we have this as a concept to try and avoid congestion. If all messages go down the same route, it could quickly exceed the bandwidth of that route and be congested, causing things like collisions. It's also good to spread out our packets because it lessens the chance of all of the messages being affected by errors en route. Let's say all of your messages are going down one cable to go to the destination. If that cable has some interference or it has some collision suddenly, or it gets cut or damaged, suddenly all your messages go down. Whereas if your packets all go in different directions, some might get affected by errors, but at least all of them won't. The key issue with this is packets can arrive out of order at the destination. So as packets are getting sent across the internet, they may arrive at the destination in a different order because they've gone down different routes. One route might have been slower than expected. One packet might have collided with another packet and had to get resent. The order isn't always the same as it was sent. And so that means without any other processing, when it's reassembled at the other end, your message would be completely wrong. Therefore, to enable these packets to be reassembled correctly back into the original data, packets also contain some additional information. This will include the source and destination IP addresses. This is important so the router knows where to send it to. We'll also say the protocol being used because this will determine how big each packet is and certain other rules. We'll look at these two concepts in upcoming videos. So if you don't know what these are yet, just wait a few videos. But for now, the really important thing to be able to reassemble it back into the original is to include a packet number along with the data in the packet. So this will be which number this packet is and how many packets are there in total. So hello is our first of 4, how is 2 of 4, and so on and so on. And at the start, this seems pointless because they're being sent in this order. However, as I say, they may well arrive in different orders at the end, but having this packet number means it's able to look at the number and reassemble it according to this order. So we get our packets back in the correct order. And all of this is really important for your understanding of how the internet works. Right, you're watching this video right now. This video hasn't been sent to your computer in one big chunk. It's been sent in thousands or maybe even millions of individual packets, some of which will arrive in different orders, but your computer is reassembling these packets back together based on this packet number. And in terms of where this video actually is coming from, well, it's coming from YouTube's servers. And another important concept is the concept of hosting. So the word hosting refers to storing a resource on a server which is connected to the internet. We looked at what servers are in the last video. YouTube will have a network. YouTube's got a lot of servers connected to that network. That network is connected to the internet. And those servers will contain millions, if not billions, of YouTube videos held as files on the server. And the server can be contacted by clients to perform a service like playing a YouTube video. To give two common examples of hosting, both of these rely on this client-server approach to networking. Web servers and file servers. Web servers host web page files and data. A web page file will include the code of the web page. Data might include something in a database, like user accounts. File servers host files, like user files, maybe photos, videos, stuff like that. A common situation is us wanting to view a web page. So what are the sequence of steps we would go through to do this? And this has come up a few times in past exams. So the first step would be the client requests a web page. In this case, the client is often the web browser acting on our behalf. This sends a message via the internet to the server requesting this web page. When the server receives this message and reassembles those packets, it will process the request. This is determining whether it has what the user is asking for and whether the user has permission to see this web page. Assuming they have got permission, the web server will respond by sending the web page to the client, usually in code form. And the web browser is able to interpret this code and show the web page to the user. So we've got this request-response communication here with some processing in the middle. Ultimately, a server is in control. It can say no to a user. To look at a slight flip side example, let's say we wanted to upload a file to a file server. We would first of all send a request to this file server requesting permission to upload a file to it. Assuming we've got the correct permission, the server will respond saying we are allowed to upload it. We would then send the file to the file server over the internet. If it's a big file, it has to get split up into all these different packets. Once these arrive and get reassembled, the server would then upload the file to the server. Now, once you understand how this works, it's a little bit obvious, but the first time you come across this, it's a little bit alien. So make sure you understand these steps and the keywords like request and response. Try and use those in the exam.